talk a few minutes in the first two slides about PhillyTalent and how and what is our program, what is our strategy with different different backgrounds other than STEM. Although we're going to talk about people coming from science and technology background, like engineering, other fields, and how that's a very growing field that are switching now to data science. So one topic is also that usually people talk about is career switch. I don't exactly like career switch because career switch implies that it's like a switch you can just do it tomorrow, and it really is about a transition. It's not exactly black and white. Most people who are doing whatever they're doing are already using some form of software, APIs, some form of data at their day-to-day work. So the idea is how to sort of expand and go beyond what they are doing right now and turn that into a transition, basically lean in and put the weight on this growing field of data science. So that's a very good way to look at it to begin with, is to start using career transition. And most careers eventually do this transition. And software engineering, it started like let's say 10 years ago, and you had topics like pattern recognition or health monitoring systems in 2002, 2005 are now called system identification, machine learning, algorithm development, AI even. So it is the same role, it's just the title that is changing. Okay, so I'm going to continue. That was 2 minutes, and go through the slides. I think we have about 10 slides for today, and if there was any questions, we can go spend more time for the questions. Okay. All right, so you're presenting this from PhillyTalent, and PhillyTalent is a service and platform product. So our platform connects mentors to mentees and leverages data science competitions, platforms to build and refine profiles for our candidates. Ultimately, the big mix of our services and our platform is oriented and aligned so that we land a job for our candidates. What we do is we basically fix the problem of accreditation in the science job market. That's what we work with. That's what we focus every day. In terms of the final service that we deliver, we build a verified portfolio for our candidates within 100 days. A very simple example is here. For example, we use some platforms here. I put here only data science competition platforms like Kaggle, AI Crowd. We use that primarily to build portfolio, build profile, have our mentees involved in data competitions, build up new skill sets. How we do that, we sign in topics. These topics comes from what we understand is going to make them a lot more, will make them position well in their job market to land a job faster. So if they are, for example, within insurance industry, and we know that a lot of work is done around Hadoop and Hadoop ecosystem, then we provide different platforms to enable and topics to enable them learn about a Hadoop ecosystem, Scoop, any other different type of APIs, Pig, queries like that. And eventually they would upload portfolios and profiles on Kaggle, LinkedIn, and GitHub. So we leverage those to ultimately source, evaluate, and update these leads for the job or candidates. So what is data science? What do we actually mean by data science? So data analyst, business intelligence, data engineer, data scientist, machine learning engineer, and machine learning R&D are the 5 tracks that we have at PhillyTalent. I was just asked, somebody was asking in a forum if he should be doing a data scientist or machine learning engineer. And there were a lot of people who were talking about it. And the way we see it, these two are completely different. So one, you're talking about modeling, predicting, talking about different measures, measure theory, L1 metrics. This is also my background. You need to have a strong statistics background. The other one, machine learning engineer, you need to have a very solid software engineering background. So you'll be working a lot of your time working on production servers, production software actually, or APIs that are in on the servers that are working. You need to understand the good practices, and not just the code, but also the architecture and the cycle of the software, the integration, the testing, all of that. So one is very focused, is around a topic, and can get really deep in that, and sort of becomes a core value of a business and a team, of a business, of a product. Excuse me. For example, if the company is in healthcare and they're working with patient data and they're predicting, like, let's say cancer, then that data scientist is key to the success of the mission, and there will be few of them. But the machine learning engineer will be the person who is going to be working with, okay, where does that code are actually going to be running on, so that people's reports and subscriptions and data is not going to be lost or be hijacked or stuff like that. So I'm going to go again and clarify what we mean by that. So data analyst, business intelligence, the key quality of this is that you're going to be very close to the business side. You need to really understand the problem more than the execution, and more than what we mean by that is the value of the problem. So where the value of the problem comes in, you're going to be designing tasks, designing timelines. It's in terms of the operations, so you can imagine doing a lot of dashboarding, doing a lot of reporting, doing a lot of presentation even to the management. So that's the type of the work that you'll be doing as a data analyst and business intelligence role. In terms of this presentation, you're talking about transitioning to these fields, right? So if somebody wants to do the transition to data analyst, and we're going to go into some case example slides in the end, but let's just, for the sake of argument here, if he's coming from, he's been in the marketing and sport industry, and now want to switch to data analyst role, and what he needs to really focus on would be business insight. So that means that sort of the resume fit in terms of the industry becomes very important. If you've been in the sport industry, the target market that you want to look at should primarily be sport industry. And a lot of people are actually doing very interesting stuff in sport with data, especially with a new regulation that is constantly changing and updating. So it's a very interesting field in both startups and classical content club, big businesses like ESPN. So business insight is very important to have that. The second part is SQL, database, and a good understanding of the databases and query language like in SQL. And then comes down to dashboarding. So these tools are off-the-shelf tools that provide the reporting, the tooling to give insight from the provided data. Okay. And then corporate experience. That's a key value to have. That usually translates into understanding the life cycle of how the decisions are made, first of all, and passed to the operation team. So the person who's going to be doing the data analyst role, business intelligence role, if he has like 2 of these 5, and the last one is programming, but usually the programming part comes into picture if there's more than one qualified applicant. And if there is that scenario, then obviously having somebody who can also communicate, hopefully down the line, with the with a technical team, with the actual team that does a lot of the development work, would be valuable. If that person who's doing the transition has at least 3 out of these 5 skills, he will be very competitive. If he's not, if he's been most of the time been just been working on running big ads, doing SEOs, then he needs to start shifting that towards one of these 5 focuses and get more idea of, okay, what are the actual cornerstones of this industry, sport industry, in terms of the data, and sees that from the perspective of the data. And I don't mean like exactly just, okay, every data is the same. No, like really go specific into sport industry, look at the trends, have more stories to talk about with respect to that, and build up on business insight. And then that's usually easy for a person with that background. And then hopefully you could do more on dashboarding and SQL. As within, let's say, doing this transition within 3 to 6 months, looking at jobs and applying and doing interviews, eventually by the end of the 6 months, he has gained some certification on some databases. He has done interesting work with some data that is relevant to that industry using some dashboarding tools, and can talk about it for like 5 to 10 minutes without boring the person who's doing the technical interview. And at the same time, the technical interviewer with at the same time, the technical interviewer would appreciate and acknowledge the problem that the person is actually solving. As I said, a key value is to be able to explain the value of the problem that you're working on when you're very close to the business side. The second topic is data engineer. So second track is data engineer. Data engineer role is, the way we see it, is a classic software engineer that uses the software tools and APIs around data. So the most important skills would be, that would be a differentiating skill, will be programming, having a solid programming background. And by that, I want to be clear. So I also put here CS, computer science. So that's completely different than CS. So you can graduate with a 2-year master's degree and a 4-year PhD in computer science, and you might still not know how to code. That's different skill. The same way that you can go to music art school and Pierce College here, and by the end that you graduate, if you don't know how to play the piano, you just don't know. They don't teach you how to play the piano. It is the same thing. So in the school, you learn a lot about algorithms, about different type of recursion, but when the technical reviewer asks you, interviewer asks you a very simple question about reversing a string, if you struggle to do that, then it's not a surprise to them, actually. You just didn't know how to, you never programmed. You've probably been doing a lot of technical work, you've been doing a lot of analytical work, you don't have hands-on experience work, which is the key thing. You get paid for every line and every commit and every code review session that you go. So data engineer, the programming is the key. We're going to talk about people coming with high school diplomas and how we think that they're actually amazing candidates for us right now. So I'm going to talk about that later. Because of this, programming, you do not need to know anything about sophisticated algorithms or complex like mathematical models and stuff. After programming experience in at least one compiled language and one interpreted language like Python, and one compiled language like Java or C++ or C, comes out a database or related language. So query languages, depending on what field you want to be in, you definitely need to have some experience with that on big data. And after that, it's about APIs. You will be working with APIs. Either you will have to build the new APIs, deploy the APIs, test the APIs, or you're going to use someone else's APIs and basically tune it, change it a little bit, use it for your application, save money, save your team and your manager money, and otherwise you have to write and code that API. So API becomes still more important than the solid CS fundamentals. And eventually, it's if you match with the few other candidates who have the same background, then usually the tiebreaker is the CS. And if you look at the way we see it, you have a good crowd of data engineers that do not come from computer science, and they actually just come from engineering background, electrical engineering, even mechanical engineering, and others. So programming SQL and APIs should be your priority if you're doing a transition into the data engineer. Data engineer, you can find entry-level positions. Data analyst, you can still find entry-level positions. Primarily, this is because the types are very different. The people who are really strong on programming at 1 or 2, 3 languages, well, let's say 2, it's really hard to find a person who is very good at more than 2. Again, it's one of the myths that people talk about is that you do not find enough good engineers, let's say in California. No, there's a lot of good engineers that actually do not have a job. So the other topic that comes into picture is that what is their expected salary? So the expected salary and the benefit and all that kind of stuff becomes a thing. And that usually is correlated with how many years of programming that person had, because programming is something you only build up over time. It's really a craft. It's really something like a craft that you have to keep doing it, trying different applications, different platforms. These platforms are not always free. Yes, Python, C++, they're free. But then if you become a data architect, which I'm going to talk about in the next role, and then those roles you're going to be paying for different accounts, whether it's on AWS or other platforms. And as I'm getting to these titles, it becomes a matter of how many years of working experience you've had. All right, data scientist, I talked briefly about it. It is heavily on modeling work. Usually, if you want to do the transition to this field, you have to invest in your degree. I would say, unfortunately, right now, hopefully that will change, and companies will look into some other things. The way we see it, the degree plays a big role. A PhD and master's or a postdoc, sometimes they have postdoc too, would play a major role in you landing the job primarily as a data scientist. And then after that, programming, probably because most of the people that do the data scientist role are actually not very good programmers. And it's kind of seems contradicting, but it is not, because a lot of the data scientist work is actually mathematics and statistics. It's got very little to do with coding and programming. So usually the tiebreaker comes in with programming, and data competition portfolio is what we'd like to see more, and we do want to say that that's an amazing player if you had to do the tie breaking, but it is not as common. If you have a strong programming language, if you have a strong programming background in 1 or 2 languages, and a higher master's or PhD degree, you will be a very easy transition, whatever field is you're in. If you're doing a PhD in literature, for example, I'm going to talk about in a slide about this. It will be super easy, very easy. In fact, a lot of data scientists come from the field of study. For example, if Microsoft is doing work with his some of his NLP product engine, or if Amazon is doing some new product on their Echo team, then they primarily look into talents that are graduated with a PhD from literature. They actually, this is where it's just start looking at. There are so many talents from that field that just apply. So if you come from a computer science background and want to apply for that position, you're probably going to be at a disadvantage, actually. But the primary factor overall, it's not the CS, it is not the programming, it's the degree and the field of your degree. And we're going to talk about it in detail later. For one example, I think I have in this slides. The last 2 are a lot less common, at least for us, but machine learning engineer and machine learning R&D, to do the transition, the two big players is having working experience 3+ years. For the same reason as I mentioned earlier with data engineering, you need to have working experience to gain that experience with some of these products that are not free, and or some of the case scenarios that you can only get if you do it in production, if you do it in real live not just development service, but production service. We test this out. Excuse me. Software engineering certifications could be a good tiebreaker if you do not have that enough working experience, or let's say your work experience has been just a database administrator, then certification on one or two of the cloud solutions could be a very good tiebreaker for you. I have seen people who actually get a job with even not having a very solid programming or CS background. And I didn't even mention the programming or CS background here. I would say you would need a few years of professional working experience, and that's more important than talking about programming at your interview. So your interview for a machine learning job, you'll be talking about 1 or 2 years of your work at a company, at a corporate setup with big fundings on their data science infrastructure, and establish yourself as a experienced software engineer. And once you did that, then to finish up for a tiebreaker, this certification could be very helpful. But the certifications that matters are usually certifications like AWS certifications, Red Hat certifications. So these are, again, like expensive certifications you have to invest in. Well, time or money, it's not that expensive, but yeah. So this is not about boot camp courses. None of this is about boot camp courses. In fact, if you notice, we did not mention any of the topics. The CS is the only one that I mentioned in data engineer. That's what the topics of boot camps comes in, and they teach you a lot of stuff in boot camps. All right, and R&D topic is very similar to the data scientist. Publications plays a major role in landing R&D roles. So usually, if you're doing let's say you've been redoing research in batteries, and now you want to switch to data science, a good angle would be working in the autonomous car industry, which is constantly growing with new IPOs like Uber, Lyft, and so forth. And one of the key things to differentiate yourself in the pool will be your publications. And I have a slide about that, and I'll go over it later. Okay, so this is a very easy slide. This is just to enforce that data science will make sense to do the transition. And eventually, one way or the other, you will end up picking up those responsibilities. If you don't do the transition, eventually you will be doing some of the scraping work, some of the cleanup work after the people who already did the transition before you, maybe 1 or 2 years before you. So why do we think that? Why do we say that? So here are a few good trends to look at and think about. Data storage is getting cheaper every year. The other two things is computing power, and for almost inbound, outbound traffic, and upload, download data that is almost a fixed. We'll see how that goes with this different regulations that are common, and we'll see which one stays. But definitely storage is becoming cheaper. That means more companies are starting with harvest data or just keep data for some time, see what they can do later with it. Machine learning tool specialization is something that started a couple of years ago. And every year you see that trend just to grow. For example, one of the common tools, H2O, is a very famous API to do the prediction and modeling, has recently got another round of investment, more than few hundred millions of dollars in round D, if I'm not wrong. And this is just an API, right? So this is an API that works with Python and R. So they have H2O R, H2O Python, and this type of off-the-shelf tools that really just make the prediction super easy, and basically click, and you have your model ready. instead of paying a data scientist and working and sweating weeks, you just run the computer and let it get it for you. Models that are very explainable, and a lot of good topics have been around deep learning AI. A few other companies are also investing in that, and controversies also starts to rise up right in this topic. But definitely every year you have more tools that are coming out, and basically makes it very interesting for big players, startups, sorry, small players like startups, and big players to switch to subscription models and do the prototyping and see what works and what doesn't work. So that's, for example, that will be completely against like somebody who is not using any, who is not leveraging any data or any computing power, and it just relying on her skills and black arts that she or he has developed over the years. So it will be just get harder and harder for her to compete and prove that he's being more productive. So that's another important trend. Another thing is the rise of APIs. So I just put one number that stood out to us for one of the reports from HackerRank. 10,000 APIs in production 2018 from almost just a little less than 500 in 2005. So, and APIs basically means, more automation. Growing pay for senior software engineers. I want to go quick over the next list of this course. Growing pay. When you're talking about data science, if you're suffering about especially about the machine learning engineer role and senior data engineer role, you're talking about just software engineers who are senior in their role, and they will love to do it because it has more pay. Another reason that they would do it, and is sometimes more the common reason, is leading versus babysitting. So a lot of senior data software engineers would rather go and be a part of the team that they can lead and have more fun rather than stay in a classic old school consulting software engineering shop where they always need to babysit new young talents that come out of school. So that's a move that has already happened, by the way, this transition from a lot of the more seasoned engineers. Those are the people who actually started the whole field. So a lot of data science talents right now are actually seasoned engineers in software engineering. Remote work, on-demand, gig economy, these are just few words that I put out there. These are real words. These are not just words. These are new trends in terms of the market and the behavior of the talents of working, doing, and seeing and respect and perceiving their work to look like. That these are few second order magnitude effect items to think about. Okay, so very little time. I'll see how I can do it in the next 10 minutes and finish up. All right, so what do you need in order to do the transition? And I'm going to go over a few examples after this slide. I'm going to start with engineering STEM talents. And with all these slides, you need to address one of these, or at least something strong for all of these four. So you should have an answer for all of these four. Perhaps sometimes you need to have a very strong answer for one, but for all of them, you need to have an answer. One, build a new portfolio. It's a new field. It's a new industry. That's where the money and investment is coming from. So doing something new makes you stand out. Data competitions, boot camps, technical schools, hands-on schools, and so forth. Immersive experience, 3 to 6 months. That's what you need to do for that. Refine your existing portfolio, whether it is in a publication that you've done as your PhD thesis or some work you've done in your master's work. Refactor it, put it on a GitHub, make it so that other people can clone it and test it and share it with people, see how people like it, create posts from LinkedIn and share it with other people, put it out there. That is something you just can do by putting 10 hours per week for an almost 10-week period. Programming is just going to make your life easier, I would say, but definitely going to make your life a lot easier during a technical interview. 1 hour for 100 days with a roadmap is a solution that you need to have and come up with, whether on your own or with someone else. Technology stack knowledge, and specifically having clarity on that. That would help you to win your interviews. So even if you're coming from social science backgrounds, and I'm going to go over one example when you want to switch to an industry in high impact investment, and someone brings up the topic of agile or ask about your industry insight when you were doing your work as a whatever it was in your own not-for-profit work, you need to have a solid idea of what software you were using and why you were using it. Like as I was saying, if you're as coming from a not-for-profit, it is more important for you to be able to talk about the value of your problem. So the clarity in explaining that becomes more important than how you did your job or what was your daily routine in your job. Like nobody would care about that. So I'll put a few examples of in here. If anybody had questions about this slides, I get to it. Risk maturity is one of my favorite questions here, but it really connects with whys. Like if you can explain to me what would be a good idea for us to use this tool versus another tool, or in other words, what are the risks of not using your suggestion versus just using it, that would show if you're a good fit for the job or not right away. All right, so this is the first example. For engineers coming from a STEM background, mechanical engineers with 4 years and perhaps 2 years of master's, they do a lot of work just graduating. I relate to that personally because that was my background almost 10 years ago too. The first thing we say is don't fail the technical interview. Don't fail the technical interview is the best strategy to focus on, because that most of the time it happens, and there are not just that many opportunities for that window of 3 to 6 months. So if you fail like 3 screen calls and 3 technical, you just failed 6 technical, and that could be it for you for that rush that you made. You need to fix the job title. Let's say you fix it on data analyst 2. Stay with it. Do not switch tracks. Do not think that you can teach yourself how to do modeling and then suddenly start applying for data scientist role. Do not do that. Back LinkedIn alumni versus going after jobs. Find what people with your background in engineering with that field they end up doing. Like as I said, this is a movement that has already started. So if you have a good numbers, if you have a good numbers, you should see already what job they're switching to, okay, and what positions they're getting. So that just is going to be your job title, is just going to give you your answer. And then hit HackerRank. Hit HackerRank every week, at least once a week. Spend time in it. Take the test. Make yourself commit to that 90-minute. You need to pass the technical interview. You have to pass that. There's no way around it. Don't fail the screening calls. I personally hope that my mentees don't struggle with that, because this is something that takes time, 2 to 5 weeks at least. It is not very uncommon. A lot of engineers do not have that time to go out and communicate and hang out and perhaps develop some of the softer skills and that they need in order to pass the screening calls. But the reason I put it this way is that engineers made good software developers, period. Like, we know that. Engineers make better software developers, so we can argue that, but than computer science people. But because of the programming importance of the job market, engineers are known to be good at software development roles. So they're expected to also be good at data science as a data science talent. So if you're a STEM engineer, this is not a real data transition for you. This is what you have to do. Unless you want to do, let's say, mechanical engineer, CAD, CAE type of work, and that's what you want to do, then that's a different story. You don't want to get into that. So don't fail on technical, don't fail on screening will be what this type of talent should work on. If you're a PhD and a postdoc, your role is going to be, you don't need to fix your role like a data engineer. All the roles is going to be available to you for a STEM engineer. For a PhD postdoc, your role is going to be either data scientist or a machine learning R&D. The hard part will be on the resume fit. So companies like Facebook, I'm going to talk about that for the data scientist role, and the profile updates becomes very important. So your GitHub is very important. You need to have that in place. Spend time on it. Data scientist role are also less common than data analyst role and so forth, and that's primarily one reason that you usually have a slightly higher salary for the data scientist role. Using APIs, for example, I mentioned a few off-the-shelf APIs and the existing trends in automation and toolings, so you have to pick that up. Startups can be actually your starting point. You might end up actually starting your professional life at a startup and just work right there, live that mentality of working with equity, and those are different type of languages that you need to help yourself, teach yourself what that means. You have to ask for whatever shares and cliffs and all that kind of work, but you can end up starting your life and professional life in a startup. Machine learning R&D is also the same. Big Five: Facebook, Amazon, Apple, Google, Microsoft. These are not just a bunch of companies. This is a $3 trillion beast. They are everywhere. So Google bought DeepMind, and DeepMind is a major big company, but it's considered a startup for hundreds of millions of dollars. And so if you want to work with DeepMind, that's a great field to go at. If you're a PhD with 5-6 years of work experience, that's a great option for you to do the transition, to go to, move to. That's still considered a career transition. For someone who has been just doing C++ and building on libraries and the statistical libraries, that's still considered a career transition, a very good one, a reasonable one. Gmail, or a lot of different products that come out of these companies, TensorFlow, you can't touch products that are not coming from these 5 companies. So, and it gets, like as I said earlier, controversy begins here. So you talk about Alexa, Cortana, Siri, all different. These are very hot topics. Machine learning R&D, some of the investments of, let's say, Microsoft in these fields in NLP started in 1985, and it is still happening, and it is still very strong. So for a machine learning R&D, we say publication leads the way. Again, even startups will be great. Will be a very good option to start with, to do the transition to and start with. Marketing, somebody who has been in the marketing for a couple of years, done ads on Facebook, Instagram, SEOs, CMS developers, all of this. So for them, a very reasonable transition would be business intelligence, a data analyst, 1, 2, and 3, depending on how hands-on they are. So if they are very comfortable with CMS, deploying, mobile apps or web apps on different servers, that could be an analyst 3. If they're if they've done a lot of work working with different marketing campaigns, then that will be analyst. Business intelligence, working closely on dashboarding and so forth. So some good industries to switch to would be healthcare and insurance. For consulting will be also a great option, the Big Four, and it would be a great option. Cybersecurity, cloud is a great topic. IoT or emerging markets, these are all going to be great topics for different reasons. I can go into reasons of why we think these are good topics. I know that we are over time, so I'm going to go to the next slide. Social sciences, So social sciences already have a strong background in understanding data. That's what everybody understands and realizes that. So a great approach would be to start with R, which is a very simple interpreted language. It is also an expert language, meaning a lot of these tools are actually developed by PhDs in social sciences. In fact, a lot of like famous grammars and graphics in R and a lot of different applications in R is developed by people coming from social science background. GIS data reporting APIs, I put few topics here. Analysts 1 and 2 they make great project managers of data teams. So depending on the topics, that could be a very reasonable 3 to 6 months transition that they could do. You could pick up a language R in 1 week and start working on GIS data in a couple of weeks and build up basically translate your current resume, your current thesis into a few GitHub repositories that other people can use, and that could be your interview topic. Philosophy and literature backgrounds, they actually make very good, they usually land data scientist roles. NLP topic is one of the key topics of, like as I said earlier, you will have a better chance of landing a job at Cortana team or Alexa team at Amazon with a literature PhD. All 5 categories, BI, data scientist, data engineer, ML R&D, are really good fits for philosophy and literature background. Simply just because in the same way that engineers proved very good software developers, so did philosophy and literature background people. So just by that, you'll be well understood when you want to do the transition, and it won't really raise that much of a flag for any recruiter. Not-for-profits, a good idea to transition would be data-regulated industries. So, first of all, it's the regulation on the products and teams, and also there are operational regulations, so data protocols and different data type of protocols that are out there, depending on the type of the data. So that is something you can start spending with if there's certification you can do. Impact investing, we don't know much about this not-for-profit transition, but we have seen people do the transition into fields with impact investment background. Okay, high school diplomas. So that's basically anybody who has no degree and graduated from high school. And honestly, this was my easiest slide putting this presentation together. It's a great time to just be a high school diploma, high school graduate right now. All you need to have is programming. So we say programming with APIs, Android SDKs, work with iOS app projects. These are very nicely developed, highly articulate in terms of documentation. So once you develop your first and second mobile app, not only you can show it to anybody, but also you're used to very good standard and very good practices. So that's right away like a great start. JS front-end technologies is going to make you very valuable for anybody who does live data streaming, which is really hard to do the automation in terms of ML. We had a slide about it, but it was one of the trends that all the tooling and how these tools becomes expert. With live streaming, it's a lot harder. And then just few certifications, that will be an icing on the cake, and boom, you'll have your first job, 45, 50K out of high school. So we are going very strongly after this type of route. So we are starting a few campaigns soon, but it cannot be sooner enough. Honestly, it's a great time to be a high school graduate right now, and so that's a few examples that I wanted to go, and pretty sure that the slide is wrong. I was supposed to finish it 10 minutes later, 10 minutes before. Thanks for staying. If you have any questions, I would love to hear what you have for me. I will go over the questions. Okay, I guess there isn't much question. And thank you so much for coming. And I will see you in the next webinar, or if anyone else on our team is presenting. Thank you.